Today we're going to talk about Einstein and philosophy. We'll begin with what Einstein and two of his friends called the Olympia Academy, a rather pretentious name for the three of them: a young mathematics student, Comrade Habicht, a Romanian student, Marie Solovin, and Einstein. They would sit around and talk about great works of philosophy line by line, sometimes spending an entire evening on one or two pages. Then we'll talk about the limits of Einstein's commitment to positivism, to the view that everything could be reduced to simply what could be seen or experienced. Next, we'll look at the link between the great movement of logical positivism, the rise of a new philosophy of science that was inspired to a large degree by what Einstein had done, and then connect that movement with a tremendously important development in the architectural and artistic world at the Bauhaus. And finally, we'll come back to Einstein and say, or ask, was Einstein a modern? Now, at the Olympia Academy, Einstein would meet with his friends, and they took apart books or papers by Ernst Mach, for example, the great advocate that everything could be reduced to the experience alone, what the human being could grasp with eyes and hands, not trying to go too far beyond the experiential. To Karl Pearson, a great statistician, biologist, and investigator into all sorts of aspects connecting experience to theory. Richard Avenarius was a prominent philosopher whose critique of experience was important for them. John Stuart Mill, who introduced a rigor of logic, as well as his famous works on liberty and equality, but whose philosophy was important for this young group of students. And then, of course, Henri Poincaré, whom we've met before. Mach was so committed to the idea that you would base things on what you could actually see or touch or hear, that he imagined, for instance, a picture where he would look just with his left eye and record precisely what he saw. He would see the limit of vision by his own nose. He would see his own body stretched out on a chair. He only wanted to talk about things that he could grasp, not atoms, for instance. He called atomism a kind of church belief in which he put not much stock. When Ernst Mach, though, applied this rigorous sense-based criterion of significance to the world, one of the things he attacked was this idea that had been handed down since Newton, that there was a notion of absolute time that lay behind any particular clocks or measures that we might have. In 1883, he wrote, "This absolute time can be measured by comparison with no motion. It is therefore neither a practical nor a scientific value, and no one is justified in saying that he knows aught about it. It is an idle metaphysical conception." Einstein took these words immensely seriously. He had read them with his Olympia Academy. And somewhat later, in 1916, reflecting on what Mach had said and on Einstein's own work, developing the special and general theory of relativity, he said this: "These quotations about absolute time by Mach show that Mach clearly recognized the weak points of classical mechanics, and thus came close to demanding a general theory of relativity, and this almost half a century ago. It is not improbable that Mach would have hit on relativity theory if, in his time, physicists had been stirred by knowledge of the constancy of the speed of light." So the Olympia Academy continued. They took on Karl Pearson's 1892 Grammar of Science. And in it, Pearson addresses this question of time and clocks. He says that Greenwich, the observatory, and all the clocks that depend on that centering clock measured equal angles from the turning Earth. We'd measure the apparent position of a star as it crossed a spider line in our telescope, and then 24 hours later see it cross again. But he said tides could affect how fast the Earth moved. You couldn't count on the fact, you couldn't ground time on the motion of the Earth spinning on its axis, because we didn't know for certain that the Earth really did spin with absolute regularity. Pearson said this: "In the world of sense impression itself, absolute intervals of time have no existence. The Olympia Academy went on. They looked at Richard Avenarius's Critique of Pure Experience in 1890, which criticized knowledge grounded outside of experience. They read John Stuart Mill's Logic, in which Mill doubted the prevailing view that has a hypothesis of a luminiferous ether. David Hume was very important to Einstein. Hume famously said that induction was fragile as a concept, and that all we saw were regular coincidences. Causality was not enough, that there wasn't something in causality that showed a connection between pushing the ball and having the ball move. We only had coincidences. This fragmentation of a too easy metaphysics was important for Einstein, and he cited it all through his life, saying how important Hume's skeptical view about easily accepting metaphysics could be. But perhaps the most important book they read was Henri Poincaré's Science and Hypothesis of 1904. They said it held us spellbound for weeks. And in the German translation of Science and Hypothesis were included excerpts, long excerpts, from The Measure of Time, Poincaré's crucial work that examined exactly what time had to be. First, Poincaré said, we have no direct intuition of simultaneity. There's no immediate grasp. That's not something that's built into us. Instead, we make rules. And the rules for how we understand time and simultaneity are there for our human convenience, not because truth is immediately and suddenly given to us. All these rules and definitions, Poincaré said, are only the fruit of an unconscious opportunism. That notion that we were given the world and organized it for our human convenience, and that there were possibly many ways of organizing our experience, but some would be simpler than others, was the opportunism that Poincaré was pointing to. And that term recurs in Einstein's own epistemology over the course of many years. All of these fragmentary bits, from Pearson, from Mach, from Mill, from Hume, from Poincaré, helped create an atmosphere of doubt for Einstein, of a skeptical, hard-hitting criticism of aspects of physics that would have seemed inevitable, necessary, a priori even. That is to say, before we even come to experience, we should accept them. These were the foundational philosophical criticisms that entered into Einstein's attack on traditional notions of space and time.